Okay, let's go ahead here out in the assembly area where we do a lot of manifold and engine assembly. Bruce and I are going to go through some of the key points of the manifold and how they're put together. And so there's some pretty interesting discoveries that were made maybe 10 years ago. Over time, 7-8 years, we've learned how to really get this stuff to deliver out evenly in both liquid and ammonia forms. And it's done with high pressure, and it's orificed about 4 times as it goes through the system. And it's the key terminal orifice at the injection point that really gives us this keen performance of uniformity and a linear streaming flow. But when you get past the engines and out to the wings and the center section, you may have 4 of these manifolds set up on a 60-foot bar. You end up with flow dividers that have to be precision, and you end up with deliveries that still have to maintain that 1% coefficient of variation as the booms shut off and turn on. So some of the key points in this, the mystery is, how do you do this? How is it all done? And so it's done with final filters, high pressure capability, and it's done with trial and error. You know, you can design it all out and test it, but when you get in the field, you really get the performance, you begin to understand it. So early in the game, we couldn't deliver many units because we had to make sure everything was right, and we kept learning things. And but the real breakthrough came about 10 years ago, when we discovered this great uniform liquid delivery was achievable with testing of live ammonia. So enough said there. Let's go ahead and explain, Bruce, what's that assembly there?
Well, that would be your final filter assembly for the NH3 side.
And there's 2 elements, right?
There are 2 different size elements, a 40 mesh and a 100 mesh, and that size is determined depending on what size primary you're using on your manifold.
Oh yeah, right. So do you have, you've got a filter open over there. Let's bring it on out. And that's what's inside of that aluminum body, is this filter element. And we also put magnets in there at the request of the producer to help capture, if they got really nasty tanks or something, we can actually catch a lot of the rust with those magnets. Most of that's done by the primary filter, which is prior to the pump. That's where most of the work goes. So you only service these final filters, maybe you'll service the primary filter 5 times before you'll even work on these final filters. And those O-rings are coated. You put silicone oil.
Silicone oil.
Yep. And what is the end cap? Yeah, silicone oil. And what is that end cap? Oh, it's double O-ring face sealed, and so it's built for very high pressure. You can probably put 2,000 psi. I've tested to about 1,000 psi, and no problems. So very substantial, heavy-duty final filter for additional safety. I don't think we've ever had. I know we've never had any kind of a problem with our final filter design, but we run clear up to 350 psi pressures in some cases. Hot days in Oklahoma, we can get right up there. Okay, Bruce, and that's what is that, an 8-bolt pattern around there, and we use stainless bolts to
8-bolt pattern.
Yep, and threaded inlet.
Stainless bolts.
Stainless bolts. Yep. And you know, I tested with in one test with the filter element out to see what happened, and filter elements make a big deal. It changed the coefficient of variation substantially. So what happens is it slows the ammonia down, pushes it through that big filter body, and then it brings it up to the accumulator. So the ammonia is coming in right here on the inlet side into the final filter body. It's filtered, and then it goes up past this adapter here into the ball valve area. Stainless steel ball valve, by the way, which gives us that extra long life and great performance. And at special request of Exactrix, by the way, we have confirmed now that everything is in stainless. Now when we get into small systems that have multiple manifolds, we may switch to a 1/2-inch ball valve for savings. We save a little bit of money by doing that because the flows are greatly reduced. So aluminum filter housing, double O-ring sealed, adapter. This is the drain down here, ball valve drain down. And this is called the BPOR. Have you got a BPOR over there? Oh yeah. See, and it's got a little smaller hole on the outlet than this one. This is a 3/8, is that right, Bruce?
Yes, sir.
This is a 1/4. And so we have these BPORs at the outlet. So when you have multiple manifolds, you have 4 different portlets, and they're all balanced. They're all exactly the same. So this port must always be the same across the width of the machine. It's called a BPOR. And back pressure orifice restrictor. And then what's this?
That would be a 3/8 line adapter that goes on your dominant NH3 manifold, and it supplies cooling back to the phase shifter.
Oh yeah, so that's where the phase shifter,
Excuse me, the vaporizer.
the vaporizer housing, so that's where it sources its flow, is from this BPOR that's located right here. It comes right on out, goes to the engine at the vaporizer filter inlet. Yes. So when you get multiple manifolds, you really have to make sure everything is balanced, and this BPOR is real key in that. And so any used systems out there, somebody's been commingling parts and components, you better make sure that all of them have the same BPOR across the width of the machine. If you got 4 manifolds, they should all be the same. So all right, and so what's on top of that, final filter housing, it comes out past this ball valve, past the BPOR, comes up into the manifold. And the manifold has these adapters that can be 3 different sizes, as I'm showing here. It can be for 3/8 lines, 1/4 lines, or 3/16 lines. So you got 3 different adapter sizes. And you can see that this is that a 36 port?
24 port.
That's a 24 port manifold. And these are called the secondary orifices, and these smaller ones here are called the primary orifices. And so there's a piston inside that manifold, and that piston moves up and down in an accumulator tube. And so we can kind of show that here right now. There's an accumulator tube, and there is a piston that goes inside this accumulator tube. Slides right in, and those are called the glide rings. These blue seals seal up very well, do an excellent job of sealing. And there's 2, you put a little silicone oil on the seal itself, and we put a little down in through there,
Down in
just
there.
very small amount, yeah,
Small.
just to give a little pre-lube. And we also have other types of accumulators. This would be a standard one for multi single manifold system. You have to have a little less accumulator effect, and so you store a little more, in fact. And so we have a short piston, standard 3-inch, and we have this long, taller piston. And then on the liquid side, we use the same manifold, and but we use a carbonate material, polycarbonate, and that piston is going up and down inside of that, shifts gears as flow changes, so you get high flow, low flow capability all the way to 350 psi. And we can use difficult materials such as chloride because of this polymer construction. So that explains the manifolds a little bit. And here is a final assembled manifold, by the way, and this is what it looks like in NH3. And this is called the Great Plains Weather Shield. It goes up and down, and we can tie it into place, and we do service work, and so this shield keeps the birds and the sunlight off of these connection points and gives us better performance in windy conditions, etc., where we just know that these high pressure lines need a little more protection with these shields. And so as we look at these manifolds, we notice that we have these various size adapters, and this one has a 1/4 inch line. And when this comes out, the line comes out of here, it needs to have a range orifice. It's really a line support orifice. There's a ferrule inside of this adapter here, and so there's a ferrule that squeezes down. You can see it right there. There's a ferrule. There it is. A little closer look. That ferrule is inside of this and ready to go, and to get its big squeeze, don't put the ferrule in backwards. Always remember that the taper needs to face the taper. So that taper goes together like that. The nut goes back on to confirm that you've got the ferrule in place. And then you push the range orifice into the, in this case, the 1/4 inch line. And there's your range orifice. And you push that on in, and then you push that into the adapter, and it takes 1 3/4 turns on 1/4 inch line. 3/8 lines, it takes 3/4 of a turn, I think, if I remember right.
A bit less.
Yeah. So that's how you, and once you pull this up tight with your end wrench and got the correct number of turns, you tug on it, you pull on it, make sure that the ferrule has made it set. It's all inside the technical manual. And so there's 3 different line sizes, and gives you the ability to deliver more or less ammonia based on band spacing. Some machines got down to 10-inch centers, so you don't want to store too much in the line, so you change your line. Okay. Now, what else have we missed? The O-rings are EPDM type O-rings. Always EPDM. And I think that pretty well explains the manifolds. Thank you.